Welcome to this WRE background video on multi-criteria decision-making under uncertainty for multi-sector systems. This title describes some of the methods that we're going to be using in the WRE planning project to identify good water development solutions for the future. The WRE planning problem, in the big picture sense, can be posed as what combinations of new supply options and transfers, which we call portfolios of options or combinations of options, meet stakeholder performance requirements and aspirations, and does so efficiently despite future uncertainty and target levels of environmental ambition. What we're going to try to do in WRE is select one or a few preferred regional combinations of large regional schemes, and we're going to try to do that informed by how they might perform under a series of different futures and considering metrics that are of interest to different stakeholder groups. The WRE project uses a technical approach inspired from the relatively new science of decision making under deep uncertainty, which has been adopted by many managers of environmental systems in the last 10-15 years. The first step of this is to simulate your system. And to do that, you need to identify uncertainties. So in our case, it could be like different hydrological futures or different scenarios with different assumptions of future water demands. You're going to identify in that simulation different options that you could implement. These are different ways that we could intervene in the water resource system of East England to develop, for example, resources like desalination, like reservoirs, like new transfers, like new water conservation schemes, all sorts of things. And the last element of simulation is to track performance. So we're going to be speaking to different, we have been speaking to for many years to different stakeholder groups, and we identify how they think they can describe performance from their perspective of the environmental and water resource system, and then that leads to different performance metrics that will track in the simulation to evaluate combinations of options. So the first step then combines those three and can be described as tracking engineering, environmental, economic, and other performance measures of different option portfolios, which include both existing and new options under a range of futures. Right. In the second step, which in this project we've often referred to as search, is that we're going to try to identify how we could combine different options into packages or portfolios of options, and how could we identify packages of options that are both efficient and robust. And efficient means that you're not going to take, you're going to try to go to combinations of options that optimize or that promote the benefits that you'd like to get. By robust, we mean that these are combinations of options that would work acceptably over a range of different futures. So we're not looking for a set of investments that would work great under one predicted future, but might fail quite drastically under others. And then the last thing we're going to do in this search phase, and this was one of the things that we focused on at the University of Manchester, is to try to identify and select between the many different portfolios of options that we could develop based on how they trade off the different performance measures. Right, and so for that we use different interactive plots. The last phase is deliberation. So that's we repeatedly and interactively look at results with different groupings of stakeholders, and we try to figure out together what would be, given the results that we've achieved in steps 1 and 2, what would be a good package of portfolios to develop in the future. So if you're a visual person, perhaps you'd like to see these steps in a more visual way. So this is what system simulation looks like. So we're going to be representing the system as a resource network and simulating over time the hydrology, the demands, and how water is put to use over space and time. WRE, this is what that looks like. So this is not the most up-to-date view of the simulator, but this gives you a good flavor of the spatial scale, the complexity, and the type of options and the the way that they're aggregated. So this is the simulation behind WRE. Spatially looks roughly like this. This slide is the second step, which we sometimes call search. And this is looking at the results of that search in different graphical forms. You can see, so on the left-hand side of the plot, you have a scatter plot, and on the right-hand side, you have a parallel axis plot. So let's start with the left-hand plot. This is showing you, so each point represents a package or a group of options, a portfolio, and they've been scored according to two metrics. And in this plot, we have resilience and cost. And you can see that those thick arrows at the origin of the plot show the direction that we'd like to get in, so the direction of preferred performance. So you can see that, the perfect portfolio of options would be at the origin there where it says best, and it would have very high resilience and it would have very low cost. Unfortunately, generally in the real world, the more you invest, the better performance you get. And so what this plot shows is for any level investment, what's the best performance that we can get. Now you can see that there are a lot of portfolios that are drawn as blue points on the left there that show, that there are many options. But if we'd like to search for an efficient combination of resilience and cost, the portfolios that are outlined in red are ones that we should definitely take a look at because they're efficient, or they're optimized, if you will, according to these two criteria. And you note that we're not deciding what's the right mix of cost and resilience. That's left up to our joint deliberation and decision maker preferences. What we're doing here is just technically identifying a group of efficient solutions. And then these are, on the right-hand side, this is a parallel axis plot. It's the exact same information, except that those red points are now red lines. But it's the same information. And the plot on the right is important because this is the way we display things in the interactive software that we use in WRE, which we call PolyVis. The last and most important step of WRE planning is stakeholder interaction. WRE is really an iterative process of planning where just different people from different stakeholder groups iterate and learn about the system and try to understand the implications of choosing different combinations of water resource development options and what that would imply for the future under different plausible futures. So this is really the most important part. We just used the modeling that we did in steps 1 and 2 to try to understand how the system works and come to what we think might be reasonable decisions regarding options that could work well or decently in the future, even though we don't really know what the future will be like.